Introduction to Statistics, Chapter 7, The Normal Probability Distribution, Section 7.2, Applications of the Normal Distribution. A standard normal probability distribution is a normal probability distribution that uses standardized scores, or z-values. A z-value is equal to the x-value minus the mean divided by the standard deviation. Symbolism, z equals x minus mu divided by sigma. The mean mu and the standard deviation sigma of a standard normal distribution are always the same values. The mean is mu equals 0. The standard deviation is sigma equals 1. So for any standard normal probability distribution, the mean is 0, standard deviation is 1. Be able to visualize the curve associated with the standard normal probability distribution. The curve is bell-shaped with the mean in the center, and you mark 3 standard deviations in each direction. So in this case, the mean is in the center, which is 0. Since our standard deviations was 1, I go 1, 2, 3 to the right, -1, -2, -3 to the left. So this is the visual for a standard normal probability distribution curve. Understand the concept of area under the curve. The total area under the curve is equal to 1 or 100%. And if you notice what we said in section 7.1, the curve approaches the horizontal axis but never crosses it or touches it. Area to the left of the mean is 0.5 or 50% because it's symmetric. Area to the right of the mean is 0.5 or 50%, symmetric. Understand that the area under the curve also represents the probability that a value falls in the shaded region. So the probability that z is greater than or equal to 0 would be equal to 0.5. That's the area to the right of 0. Another nice feature of the standard normal curve is that it is symmetric. So the area to the left of -2 is the same as the area to the right of +2. So if I look at my curve, I have -2, 2. That shaded region to the left of -2 is 0.0228. The area to the right of +2 is 0.0228 also. So it is symmetric. Also remember that the standard normal distribution, P, probability that z is greater than 5 is the same as the probability z is greater than or equal to 5 and has the same value. And this is because the probability z equals a value is always 0. And that's why greater than equal to have the same value. Also, probability z less than or equal to less than 4 is the same as probability z is less than or equal to 4 and has the same value. You're going to need to understand this when you use StatCrunch. StatCrunch does not have greater than or less than symbols. They just give you the option of less than or equal to, greater than or equal to. Now, using the standard normal distribution tables. In your tables and formulas, you will be given the standard normal table. I'm going to go through how to use it, even though you're probably going to use StatCrunch for most of your problems. But I think understanding how to use the standard normal distribution table is important. Okay, first, the table uses standardized values or z-values. The z-values are rounded to 2 decimal places. The table gives the area under the curve to the left of the given point. To find the area to the right of a point, take 1 minus the area to the left of the point, because remember the total area is 100% or 1. To find the area between 2 points, subtract the area to the left of the smaller point from the area to the left of the larger point. Okay. Now, tables were created because way back we didn't used to have calculators, we didn't have computers, so everything was done by hand. So we could take any normal distribution and standardize it using that formula, z equals x minus mu divided by sigma. And once it was standardized, we could go to the tables, and we didn't have to use some ugly formula. Okay, any z-value less than or equal to -3.50 or greater than or equal to 3.50 has an area of 0.0001. In other words, we said it's never going to touch the horizontal axis, so there's always going to be some small area out there. And we're going to say once you get past negative 3.5 or positive 3.5, we're going to call that area 0.0001. Okay, an example. Using tables to find probability z less than or equal to negative 3.23. Well, first, your z value is negative, so you're going to go to the negative z-scores. Now, next, find negative 3.23 in the table. Well, down the left side of the table, you will see z values. These are only one decimal place. So first I'm going to do is I'm going to find negative 3.2 down the left side. So there's negative 3.2. Now I have the 3. Across the top, you notice these are 2 decimal places. So this is where you'll pick up that second decimal place. Second decimal place is 3. So I pick up 0.03. So now I have negative 3.23. What do I do to get my answer? Well, I come across from negative 3.2 down from 0.3, and where they meet, I get 0.0006, and that becomes my answer for the probability less than or equal to negative 3.23. Okay, now let's look at a second example. Using tables to find probability z greater than or equal to 1.36. Look at the z value, it's positive. So this time I'm going to use the positive z table. So down the left side, I'm going to find 1.3. So here's 1.3. Across the top, I'm going to find 0.06. So there's 0.06. Where those two meet, so I come across, come down, it's 0.9131. Now, the problem is, this is the area to the left. This is the area to the left of 1.36. But if you look at the problem, you want the area to the right of 1.36. So now we have to use the fact, since I'm looking for the area to the right, I have to take 1 minus this answer. So you take 1 minus 0.9131, and you get 0.0869 for your answer. So you have to be careful. Remember, the tables only give you the area to the left. If you want the area to the right, you find the area to the left and subtract it from 1. Now, using tables to find the probability P is that z is greater than or equal to 0.45, less than or equal to 2.17. This is an interval. So first, you would draw your curve, locate 0. Where is 0.45? 0.45 is just to the right of 0. Where is 2.17? It's out here further to the right. And what do I want? I want all the area in between. Okay, shading is a little difficult on the computer. So that's the area I want. So how do I find it? Well, first off, I find the area to the left of 2.17 using the table. So that turned out to be 0.9850. Then I use the table, find the area to the left of 0.45, which is 0.6736. Now you notice that green shaded area is the difference between these two values. So I take the difference of the two values and I end up with 0.3114 for my answer. Okay, so this is how the tables would be used to do a less than, equal to, greater than or equal to, or between. Okay, now let's look at using StatCrunch. Okay, so first you're going to click the question help, top right question, to open StatCrunch. Then you're going to click Stat on the top menu, click Calculators, click Normal. You're going to enter a value for the mean. Now remember, if it's standard normal distribution, the mean is 0. Enter a value for the standard deviation. Again, standard normal distribution has a standard deviation of 1. Choose the correct inequality, less than or equal to, greater than or equal to for your problem. Sixth, enter x value. This is your z value in a standard normal distribution. And click compute. Okay. Now, so let me look at this problem. Let me shut this off for a second. Now, we had found earlier that this was 0.006. Now, using StatCrunch to find it, what you would do is first you open StatCrunch. I've already got it open. Then you would click Stat on the top menu, highlight Calculators, go down and click on Normal. Okay, so you have this picture show up. Now, the mean we said was 0. The standard deviation is going to be 1. I want less than or equal to, and now I need to put in my z value, which is negative 3.23. So I put in negative 3.23 and click Compute. Right here is your answer, 0.006185, and you round it off to 4 decimal places, you get the same answer we had before. Okay, so now, if I go back here to the slide, you know, I said click to open StatCrunch, click Stat, going through everything I just did physically. You would enter it, you enter the mean, you enter the standard deviation, you choose less than or equal to negative 3.23, you click Compute, and your answer appears. Okay? And then you would round it off to the desired number of decimal places. So that's using for the same problem we did earlier. Now, what about this problem we did earlier? We did this problem earlier. Well, you would open StatCrunch, click Stat in the top menu, then Calculators, then Normal. This time, you enter the mean of 0, you enter the standard deviation of 1, which is default. It's always going to come up 0 and 1, so if you're doing standard, you don't have to worry about changing those. It comes up 0 and 1. Then I'm going to choose greater than or equal to 1.36, click Compute, and my answer would be the 0.08691496, round it off to the desired number decimal, and we get the same answer we got using the tables. Now, let's look at it going through it in StatCrunch. Okay, so I already have, if you wanted to, let me close this down. You would hit Stat, Calculator, Normal. Mean is 0, standard deviation is 1. I want greater than or equal, and I want greater or equal to 1.36. Hit Compute, and there's your answer, 0.08. You can see this is much easier than using the tables. All right, so close that, go back over here. We already did this. Now, using StatCrunch for between. Now, this time, you're going to do the same thing. Open StatCrunch, click Stat, highlight Calculators, click Normal. But this time you have to click Between at the top. And now you get a graph that looks like this. So you enter the mean, which is already there, 0, so you don't have to do anything. Standard deviation, which is 1, it's already there. Now, this time, you're going to enter the left and right end. So it's 0.45 on the left, 2.17 on the right. Then you click Compute, and your answer appears, 0.3113. This is much easier than using the tables where you had to find 2 different probabilities and then subtract. So get used to using StatCrunch. Okay? Now, let me go back and do it in StatCrunch. So I Calculator, Normal. This time up here at the top, I'm going to click Between. When I click Between, this area down here changes. Mean is 0, standard deviation is 1. On the left, I wanted 0.45. On the right, I wanted 2.17. Click Compute, and you notice I get the same answer we have over here when we round it off. Okay, so that's using StatCrunch. All right, next, remember the old saying, a picture is worth 1,000 words. Well, in statistics, that is very helpful. Find the area less than z equals 2.15. Recall this is also probability z less than 2.15, and the probability z less than 2.15 is the same as probability z is less than or equal to 2.15. So we sketch a curve. 0 is the mean, so it's in the center. 2.15 would be to the right. So I draw a vertical line at 2.15, shade everything under the curve to the left because I wanted less than or equal. So you notice this is going to be greater than 50% of the curve, isn't it? So it's greater than 0.5. That'll help you check some of your answers. So that's greater than 0.5. Use StatCrunch to find your answer. So in this case, if I wanted to use StatCrunch, I would go under Stat, Calculators, Normal. I want Standard, 0, 1, less than or equal to 2.15. Click Compute. And you notice I get 0.984222239. Okay? Which I'd round off to 4 decimal places, 0.9842. Okay? So that's using StatCrunch to answer that question. All right, now continue using StatCrunch to find z-value for a given area or probability. First, understand the problem and understand relationships between areas under the curve. Okay, recall that mu is 0, standard deviation is 1. So the area to the left of the mean is 50%. The area to the right of the mean is 50%. Also, if the area to the left of z is less than 50%, or 0.5, then z is less than 0. Does that make sense? If this shaded area is less than 50%, that's going to put z to the left of 0. If the area to the left of z is greater than 50%, then z is going to be greater than 0. So if this shaded region is greater than 50%, that's going to put z over here on the positive side. Now let's go with if the area to the right of z is less than 50%. So here is z. This area over here is less than 50%. So remember, 50% is right here in the center. So if this is less, it's going to be positive side. And if it's greater than 50%, z is going to be on the negative side. So if this shaded region is greater than 50%, that puts us in the negative. Now, if the area to the left of z is 80%, then the area to the right of z is 20%. Because remember, it has to add up to 100% or 1. So if this shaded region to the left is 80%, the region to the right is 20%, 0.8 or 0.2. All right, using StatCrunch to find a z-value when an area or probability is known. First, click the question help at the top right of the problem to open StatCrunch. Click Stat on the top menu, highlight Calculators, click Normal. Third, enter a value for the mean. Remember, standard normal, mean is 0. Enter a value for standard deviation, standard normal, 1. Choose correct inequality, less than equal or greater than equal to for your problem. Enter area in the answer box. Use decimal form. Okay, this time we're not going to put a z-value in. We're going to actually put the answer in. And then click Compute. So if I look at this, find z such that 25% of the area under the standard normal curve is to the left of z. Well, look at the diagram. Since it's 25% to the left of z, that puts z on the negative side, and that shaded region is 0.25. 25% is a decimal. So now, I use StatCrunch to find my answer. Well, let's see. Let me end this. I would go in, open up the normal. This time the mean is 0, standard deviation is 1. Now I wanted less than or equal. I'm going to leave this blank, and over here I'm going to put an answer in. I'm going to put 0.25. You notice when I come over here in the answer and start punching, the z-value disappears. So I don't have to erase the z-value. It'll automatically erase when I put an answer over here. So I want 0.25 and I want less than or equal. Click Compute. And my answer turns out to be negative 0.67448975, rounds off to 0.67. Okay? So let me go back over here. This showed you what you would put in, and this shows you the output, which is what we just had for our output. So then you would round your answer off, so z is negative 0.67. Find z such that 65% under the normal curve is to the right of z. Well, 65% of the right of z, so that puts z down here to the left of 0 again. 65% is 0.65. Use StatCrunch. The mean would be 0, standard deviation would be 1. I would choose greater than or equal to and put in 0.65 for the area. Excuse me. And click compute. Now, I think you're pretty good on this now. So, this is what you would see when it appears. So that's z equals negative 0.39, rounded to 2 decimal places. All right, find z such that 80% of the area under the standard normal curve is between negative z and z. Draw the diagram. So 80% is between negative z and z, which means 10% is in each tail. But now, thanks to last semester, they've upgraded StatCrunch. We used to have to find z and then realize negative z was the opposite. Now we can use the between. So in the calculator, you would click between. This time, mean is 0, standard deviation 1. We leave these two blank and we put an area in. The area between is 0.8. Click compute. When I do this, this is what you would get. Okay, so let me run through this quickly on StatCrunch. So, I'd hit Stat, Calculator, Normal. Click between. Mean is 0, standard deviation is 1. The area between I want to be 0.8, 80%. Click compute and you notice I get negative 1.2816, 1.2816, which is what I have over here. You round it off to 2 decimal places. Okay, and that's using StatCrunch. So you can see StatCrunch is going to be a savior, but you have to understand the problem first. All right, next, find the value of z sub alpha. Okay, the notation. Z sub alpha is pronounced Z sub alpha. Is the Z score such that the area under the standard normal curve to the right of Z sub alpha is alpha? So here would be Z sub alpha. So the area to the right I want to be alpha. Okay. So find the value of Z sub 0.15. Well, use StatCrunch to get your answer. The mean is 0, standard deviation 1. I want the area to the right to be this, 0.15. So I pick greater than or equal to. And then I put 0.15 in for the answer. Click compute. And here would be my answer. 1.036, so rounds off to 1.04. Okay, by using StatCrunch. Now, using StatCrunch to find area probability for a normal distribution. We've been dealing with the standard normal distribution. Now we're going to do the normal distribution. The only thing different between the normal distribution and the standard normal distribution is you're going to have to put a value in for the mean and a value for the standard deviation. But other than that, everything else works the same. So you're going to click Question Help, open StatCrunch. You're going to click Stat, highlight Calculators, click Normal. You're going to enter a value for the mean, but this time the mean is going to be given in the problem. Then you're going to enter a standard deviation. It's going to be given in the problem. And then you just choose the correct inequality, less than equal, greater than equal. Enter x value. The x value is given in the problem. And click compute. So, example 1. If mu is 80, sigma is 5, and we want the probability x is less than 83. So we draw a diagram to understand where x is located and the area you are looking for. Okay, so take a second, draw your diagram. So there, 80 would be the mean. That's in the center. So 83 is to the right. Okay. So I want the area to the left of 83, so that's shaded to the left, which implies what? This answer is going to be greater than 0.5, isn't it? It's greater than 50%. Use StatCrunch. So this time you put 80 in for the mean, you put 5 in for the standard deviation, you choose less than or equal to, and you put 83 in for the x value. Click compute, and this is what would appear. So let me just run through that. So I think you know how to open it. So I'm just going to change the mean here to 80. The mean is 80. Whoops, I got to go to standard. Don't want between. So the mean is 80. Standard deviation was 5. And I wanted less than or equal to 83. Okay, I click compute, and you notice I get the same thing that's over here on this screen. Okay, the only difference between normal and standard normal is normal you have to put in a value for the mean and a value for the standard deviation. Standard normal is 0 and 1, and it's automatically put in for you. Now, so this is what we got. Now, let's go back to what we talked about interpreting the answer. Okay, the answer is 0.7257. What does this answer mean? Well, if you pick a single student at random from the class, the probability the student scored below 83 is 0.7257 or 72.57%. So that's the probability part of the question. Now, the second part is proportion. The proportion of the class that scored below 83 was 0.7257 or 72.57%. So this means that 72.5% of the class scored below 83. Okay? The first one was a probability. The second interpretation was a proportion. These are the two interpretations your author uses. All right, example 2. The mean is 80 again, standard deviation is 5, but this time I want between 70 and 79.4, which is actually a C, right? So if I end this for a second, if I go over here to my calculator, so let me start at the beginning. Calculator, normal. This time I want between, so I click between. The mean was 80. Standard deviation was 5, so I put 5 in for standard deviation. Now, I want between 70 and 79.4. Click compute. So I get this answer, 0.4294. So this would be 0.4295. Okay? So if I go back over here to the PowerPoint, okay, we just put all that information in, we click compute. This is what we got out. So your answer would have been here, which is 0.4295 to 4 decimal places. Now, what does this answer mean? Well, if you pick a single student at random from the class, the probability that the student received a C on the exam is 0.4295 or 42.95%. Second, the proportion of students in the class that received a C on the exam is 0.4295 or 42.95%. So this is how we interpret the information and also how we find it. Using StatCrunch to find an X value when an area or probability is known. Okay, again, you open up StatCrunch using the question help. You click Stat, highlight Calculators, click Normal, enter a value for the mean, enter a value for the standard deviation, choose correct inequality, leave X value blank, and enter area in the answer box, just like we did before with the standard normal. Click Compute. So, given mu, find a cutoff for the lower 15%. Well, first understand the problem, understand the areas under the curve. Okay, probability X is less than or equal to the cutoff, which is 15%. So, The probability x is greater than or equal to the cutoff is 85%. So it doesn't matter which one you use. You could use less than or equal, or you could use greater than or equal to, but you got to realize what percentages you have. So use StatCrunch to find it. I chose less than or equal, so less than or equal is 0.15. Click compute, and this is the graph you get. The mean was 90, standard deviation was 5. I wanted less than or equal to be 0.15. So I got this for my answer right here. Okay. Now, what about the cutoff for the upper 20%? Now you got to understand what the upper 20% is. So now I want greater than or equal to the cutoff to be 20%. Less than or equal to the cutoff to be 80%. So I chose greater than or equal and put 20% in, 0.20. And this is what you would get at, just like we've been doing. You have the 90 for the mean, standard deviation of 5, greater than or equal, 20%. And this answer appears. So the cutoff is 94.2. And this brings us to the end of section 7.2.